Hey, this is Steven from LegitTechTutorials, and welcome back to our shredder design, our product design tutorial series. And so we are back working on the dimensional control module and the automatic spooler module. And I've been printing, you might hear my printer go in the background. I've been printing some parts, so we're going to take a look at some of the parts now, and I'll tell you some of the changes that I've made in those parts, and what I would suggest, and what we're going to do from here forward. So it's 23, okay. Okay, give me 1 second, let me put this bad boy up here. Alright, so I go ahead and have my my webcam here. And here is, so I have a few things here. I have a few, these are actually bearings. I don't know if you guys could actually see that, but those guys are bearings. And here's another bearing. So these are a few different settings. So first things first, let's go over this guy. This guy's the roller, and you see that it was been changed quite a bit. Let me get my orientation down here really quick. So you can see that it's changed quite a bit. That it now has a bigger hole, and what it's actually inside is it's actually tapered. It has that same hole that this pulley does, if you remember. So I'll go ahead and show you guys that change here really quick. Let's go ahead and move this guy over here or so. Or maybe even up here. I like that. Okay. So let me go ahead and show you guys what I did on that. Oh yeah, and also sorry about my dirty desk. Okay, so this guy was set up. What the hell? Something bounced off my shoe. Okay. This was set up for these larger bearings. So those bearings were definitely too small to have set up that way. You can see here the taper, because the issue with that flat spot I had is that would be hovering whichever side was flat. That if this was closed there, if this was just flat and closed, it would be hovering. So again, I had to do the 45-degree taper, just like we have on the that pulley that I showed you. So 45-degree taper, and then on the other side also 45-degree taper, and also this hole is adjusted for the pulley. And you'll notice here for the pulley that these bearings fit in there. Also, these bearings are going to need some work because they're too close to the outside. So what happens is that they're fusing together. I can't break it free. They do work when you could break them free. So I can't hold this inside hard enough and twist this that it's able to break free. But yeah, as you can see, those guys fit in those guys pretty snugly. So if I change that inside, I might have to increase the outer diameter, and then I'll have to deal with that. And then obviously this guy, this pulley, is going to have to also be changed there like that as well. So that's going to have to also be drilled out. Okay, so looking at the two pulleys, here is the original pulley. So this is the original design here, and you can see that we had some issues with it. I don't know if you guys could see that right here. Basically, this contour, if you look at it right here like that, this contour is too extreme of an angle that this is printing over nothing too much. So what happens is my printer doesn't have that good of cooling. I have a console, so printer's not that good at cooling. So this guy is just lifting here. So what I did is I just decreased the top diameter. So if you look at the two here, compare the two, quite a bit of change here. Let me show you guys. It's quite a bit of change there. It's I think I dropped it probably dropped it a whole inch or so. And now this guy has really smooth corners, really nice, but I don't know how well the filament is going to stay in that groove. So what I might do is I might go onto this pulley and just do a 45 and then revolve it. So that way we get the filament to stay right in that hole and not go up and down on the pulley, and also eliminate any issues with this little sharp point here at the top. So I'll change that, and also I'll give you a look of that on here. That would be the spooler module. That would be here. So you can see now it's quite a bit smaller in the spooler module. Quite a bit smaller. So yeah, this is also going to need to be opened up, meaning that this guy is definitely going to be a lot hollower. But what I'll do is I'll probably first turn this into a V and then revolve that. So I'll probably completely redesign this one, get rid of those 3 planes, and pretty much start from scratch. Alright, go ahead and open up the next one while I show you guys. So here, let me see what the one I started with. I started with this one, which was the this is the one where the pulley attaches to, where this guy attaches to here like that, right? And then this guy goes up and attaches to the big assembly, if you see here on my main screen, that big assembly there. So this is what we started with, right? So it was really narrow. What was the other issue with it? Yeah, it was a little narrow. Here I wanted to have a little bit more thickness here, and I also wanted to create a web between each of these barrels. So what I did is I redesigned it really quick, and I printed it, and then I don't know if you guys could see that, but now there's a web. Now there's a web between those 2 barrels, if you can see that. So now there's a web here and a web there, so now that gives a little bit more rigidity. And then maybe I'll even put some gussets or something that go up and down like that. Maybe, maybe not, I don't know. So yeah, now some gussets. Put this over here so we don't have that shadow. Okay. And again, sorry about my messy desk. So here are those gussets that I'm talking about, and that is the adaptation that I did on that guy. Alright, another one is I printed the cone. Let's go ahead and open that. So here's the cone, and accidentally on the first one I was printing it like this, with this way up, and that's not going to work because there's a square. That's the part I was talking about on this guy that I needed to avoid, is that if it was printing like this, this flat spot would be hanging over nowhere. So you guys can see that flat spot of the square. So it had to be printed like this, which I was kind of worried, you know, with the small surface area of this attaching down to my plate. But a trick that I learned from one of my buddies that I'll share with you guys now is that if you're using blue painter's tape, which is what I use, take a piece of cloth or whatever, and then put some rubbing alcohol, 99%, 99.99%, 95%, whatever, rubbing alcohol, and then rub down, put it on your cloth and rub down the painter's tape. And you'll notice that the grab that the painter's tape has almost doubles to triples. I might have to do a video on the Green Engineers researching that with actual, you know, data as far as the pull it requires. But it'll actually double the amount of, like, how cinched down it is to the table. It'll actually, like, double it. So what you could actually do is you could actually control how hard it's grabbing onto the painter's tape, whether or not you clean the surface or you don't. So if I don't want something to stick as much, I won't clean the surface. If I want something to stick way better with this, way better like this, I'll clean that surface and make sure that it sticks good on there. And as you see, it's stuck really good. And I had to, like, grab up here on the top and then, you know, twist it back and forth to get it to pop off. But yeah, it would have been a lot more beneficial if it went like that. So maybe I'll do, you know, a taper there, I don't know, who knows, to even decrease the amount of volume that's in here as well. And another thing I wanted to show you guys about this one is how it looks like when I shove it into a spool. So I have a few spools over here. Let me grab, okay, so these are two different spools. Totally forgot that you should be doing this spools here. Okay, so here's a Proto Paradigm spool. As you see, Proto Paradigm. And then here's the cone. And the cone fits in that guy. So again, this will have like some rubber on the outside to allow me a better coefficient of friction on here so that it actually grabs on. As you see, fits in there perfectly. And that's like one of the bigger holes, and you see that I have about an inch or so of taper left. So that's the Proto Paradigm. That's probably the biggest hole that I've seen on most filament spools. This guy is the Shaxson or whatever. The Shaxson, which is the Fry's filament. You see it's got a small hole. This is about, I think it was 1.5 inches. Or 2 inches, 1.5 inches, something like that. And then so as you see, boom, fits in there. Again, it would have rubber on there, but fits really nice in there. Again, it would have one from this side and then one from the back. So that worked really well. I didn't change this one. This one's unmodified. We'll go back to talking the bearings, because the bearings are probably going to be the most challenging part. So here is that little wishbone, the pulley bracket, which you see here on my main screen, the pulley bracket, which is this attaches to this. So the pulley attaches to this, and then this attaches to this, and then this has two shafts that go up through that hole, and then this guy has a spring that goes up top. I have yet to print those two big ones. I haven't yet to print this one. Actually, I totally forgot to print this other one here. I haven't printed that yet either, so I think about it, whatever. I'm already in the video. And I haven't printed that one yet. I'm not going to be able to print it here. I'm going to have to print that at Tech Shop because they have the larger MakerBot. Oh yeah, so back, and this was actually a big change for me, and I'll explain why. So this guy, right? What happened is when I went on my Repetier host and I sliced it, it did some weird thing with this little narrow piece down here. It didn't fill it. It didn't put any infill on this piece. So like here, it didn't start putting infill till all the way up here somewhere. So if I put my finger the other way, it didn't start putting infill till about here. So this was all hollow. And I was like, well, why would the slicer do hollow and not put 15% in there? So the slicer was just doing some dumb crap, and then was doing whatever. And then this was all infilled. So like this wasn't infilled at all. It was super weak, and it was just like flexing like crazy, whatever. And then like this was okay. This was fine. So like why? These both were jacked up, and then until here, and then there it started to like infill from a side, and then that was over nothing. So the infill was not attaching correctly because it was just infilling over thin air. So for the first time ever, what I did is I switched my Repetier host slicer to using Cura, which I've only used Cura a few times, but not very much. Mainly at Tech Shop if I wanted to work on their one of their simple metals, their printed by simple metals. But I've not been using Cura at all. So this was definitely a big change, and the layout for the settings is a lot different and a lot stranger to me. But when I went in to slice this guy sliced perfectly. It had all the infill in the right spot, and it had good estimation of time, quick slicing, very, very quick slicing. Even on my shitty, my laptop from maybe 6 years ago, that's what I used to drive my my console. So yeah, so worked beautifully, did a beautiful model, lowered stringing. Stringing's okay. You'll see stringing on the bearings, but overall, very, very good model. And this guy's perfect. Holes were perfect. pretty much. Holes are perfect, that hole's perfect. And this was printed like that. No problems at all of it. You know, like I said, I went in and cleaned it first. Cleaned it quite a bit first, and then put that guy down. So yep, this guy now attaches that guy. Oh, now I thought about it. Shit, I totally forgot about these holes. These holes here. Derp. I don't know if you can see what I'm talking about, but there's these two holes here. I didn't even think about this guy connecting like that, and then over those two holes. So I'm gonna have to do something about that. Alright, well, derp. That's a derp moment. Alright. Anyways, so let's go back and talk to you about these bearings. So I've had a few issues here on, my console has a lot of loose belts on it, so it jumped a tooth here and put this piece here on it. I'm sure you could see that. It jumped a tooth. Right. And also this one obviously is going to be way too bonded to free. And then this one, which was really good. Also, by the way, these both are ball bearings. So they're ball bearings, and they have a specific dimensions in order to get them to work properly. This guy was a little too bonded, so basically what you do is you go, I went on to Thingiverse, and I went into the customizer for this ball bearing, and you just enter in the information you want, the inner hole diameter, the ball size, the ball diameter, which is the height of the bearing, the inner radius for this inner piece here, this inner piece right before the balls, that diameter, and then, like I said, the ball diameter, and then the overall radius diameter. And then in between that, you have the number that goes from the wall to the inner diameter, and then the wall to the other diameter. The other radius. So the distance between the balls and this radius, and the distance between the balls and this radius. So that number is what keeps it floating, so that it's easy to break free and spin. But the smaller it is, the bigger the number is, the more slop you have. And I printed this once before. I gave it to my dad, so I don't have it anymore. But it had one, I think it was two less ball bearings in it, and what would happen is it was easily freed. It had the stock settings, so it was just like boom, and it opened up. And then each of these, what would happen is some of them would space out down this way, would have like a little space up in here, and then so you could just like push the center ring, you could push the center radius up in there, and so there's a lot of slop, the X and Y. And then there's a little slop on the Z. So that should be fixed, because now I have the correct number of ball bearings in there, to where it just fits all the way around. Maybe too much, I don't know. And then so I just need to probably maximize the distance between the two pieces there. But overall, this looks good. This will work fine in this little guy here. And then this one, for whatever reason, compared to the other one, fits really loosely. And there you go. So then you put the shaft in there, you guys spins, and then even this guy's got the little ridge there. Ridge is hella small, but this is the 1.75 version. There will also be a 3mm version where you swap these guys out, or you probably even run the 3mm in there, and it should be fine. Alright, so, oh yeah, here's a fail for whatever. I think it was one of my motors was getting hot, and then it was skipping steps, so it just kept like pushing the hot end in there, and then it just started building up, and then you hear it jumping, jumping over the infill, and so you go over there and cancel it. And so there's something to go into my recycle bag. Another thing is I had another fail, which here's an outside ring of a bearing. It's actually really cool. the customizer. This was a convex. This was a convex bearing. So here's the little ball bearing that went in it. Not a ball bearing, but a convex. It's a roller bearing, roller type. I don't know if you could see that. Probably not going to be able to. But yeah, it's a convex roller bearing, and I got it free very quickly, and then like I just pushed on it, and then all of a sudden all these guys popped out. You know, all these guys came free and just rolled around the floor or wherever. Because in that one, it doesn't allow you to pick how many rollers you have in there. And so it only had like 4 rollers. Anyways, that is pretty much it. So I'm going to be working more on getting these guys finalized and printed, and then I'll go over the changes that I do for each iteration, and then we'll be ready to print out entire one and put it together, and then write the program that controls all of them, and talks to the multi-shooter and allows us to get perfect 1.75, 3 mil, or 2.85, or whatever filament that you want, and then automatically spool it up and then be ready to go for you. Alright, so this has been Steven from LegitTechTutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like in this series and other series as well. I'll see you guys in the next video. Again, I apologize for my dirty desk. I'll see you guys in the next video. Thanks for watching. Take it easy. Peace. See you guys in the next one.